Ah,
It says
there we go.
record.
Okay, so we're looking at a review for distance, time, and speed. So yesterday we said that distance would be your path traveled, and distance, a symbol, is a lowercase d, and the units are some kind of a meter usually, so a kilometer, a centimeter. We can also have miles when we're talking about distance, okay? It's not metric, but it's still something we use a lot. Next time we talked about the thing was a time. So time is a lowercase t, and we're talking about the passage of, or as, oh, I hate saying the word time, as time goes by, but we can measure it in, or the units are hours, seconds, minutes, usually. We can also have year as a time unit. Then we have speed, and we have a lowercase v for speed. It's not the s, it's a lowercase v. And we have acceptable units. One is meters per second, kilometers per hour, and then miles per hour. Okay, those are all acceptable speed units. Then we talked about uniform motion, and we said uniform motion was when we had a constant speed in a constant direction. So we don't change direction or speed. And uniform motion was the most simplest kind of motion. Then we had non-uniform motion. In non-uniform motion, either the speed is changing, either you're speeding up or slowing down, or you're changing directions. Or, I guess, it can be both of those for non-uniform motion. Okay. So, after that, we talked about instantaneous speed. And instantaneous speed was speed at a moment in time, one particular moment in time. And we know when we're looking at instantaneous speed and a car driving, if you look down at your speedometer at that particular moment in time, that would be your instantaneous speed, okay, at a particular moment in time. And this one said, what is the vehicle's instantaneous speed? Well, it depends on the moment in time, okay, so 110 kilometers per hour. Okay. I want him to do that. Next one is average. If we're looking at average speed, the calculation of the change in distance over the change in time. So this little triangle there, that always means changing, okay? And you will see that a lot. We'll talk about velocity, we'll talk about acceleration, speed. This one is delta D, change in distance. Okay? And acceptable units, again, for speed, for average speed, is still kilometers per hour, meters per second, and miles per hour. They're all good speed units. Notice here we have VAV, average speed. For instantaneous at one particular moment in time, it's often VIN, instantaneous speed. Okay? This is your average speed. Also, especially for us, often if you see just the V, that means average speed. Okay? You'd have to indicate instantaneous somehow. So if it's just the V or VAV, we're talking about average. So So we talked a bit about what average speed would be. So if you were driving and you were speeding up a little bit, you were slowing down a little bit, you stopped for a little bit, that would be, all of those would be the change in the distance over the change in time, the total distance over total time. So, let's see if this one works now. Nope. We need to know what these variables mean before we can use our equation. So, delta D. We know D is distance. We know delta is a change in. So, of course, delta D means your change in distance. Anytime you calculate a change in something, it is your final, which is the D2, minus the initial. Final minus initial. So it says here D1 is the starting distance. Often it starts at 0. Not all of our problems will start at 0. But it's the final minus the initial is your delta D. Delta T, well, we know delta means change in and T means time. So the change in time. And delta T, in order to calculate it, you take your final time minus your initial time. So T2 minus T1. Okay? Final minus initial. I'm not even going to try it again this time. Okay, let's look at this example. When we do these questions, we always have to do them the same way. We want to read the question. We want to write down what we know and what we're looking for with the correct variables. We want to manipulate our equation. We want to put in our numbers. We want to solve. We're going to write down the unrounded version and then the version of your answer with significant figures. So we're always going to do it the same way. So it says a car travels a total of 420 kilometers and it takes 4 hours. What is the average speed? So I read the question, now I have to write down what I know. And I know my D, distance, is 420 kilometers. So you can't just write 420, you have to write down the appropriate symbol that goes with it. Okay, distance is a lowercase d. Time is equal to 4 hours. Okay. So we want our answer to be in kilometers per hour. Our units are kilometers and hours, so we're good. So we know that we're looking for the speed is distance over time. Distance is 420 kilometers and time is 4 hours. So we want to take 420 and divide it by 4. So pull out your calculators and get that a try. 420 divided by 4. 105?
Yeah.
Okay. So 105. That's what pops up from the calculator. That's what I'm going to write down. Then I'm going to say, yeah, but I am in science class. Can't just copy down what from the calculator. I do have to do significant figures. How many sig figs should I have? 1. Excellent. This one has 2 sig figs. This one has 1 sig fig. So my answer can only have 1. So what will this be with 1 sig fig? Just 100. Yeah, perfect. So 100. Okay, we got that part. Again, I'm in science class, so I have to put down my units. So I'm going to have to record it as kilometers per hour. And I'm just going to put the V in front saying speed is equal to 100 kilometers per hour. You don't need a sentence. I don't care if you put that in. If you do, that's fine. I need to know where your answer is. But if you just say V is equal to 100 kilometers per hour, that's fine. Okay? Remember to record the unrounded number first. Any questions on that one? Okay. Time and you just from here. Okay. So we still have this example. Ty, do you want to push that again? Okay. We have Fred and Ted. Fred and Ted. On the school canoe trip, Fred and Ted's canoed at an average speed of 8.2 kilometers per hour. On average, how long do they need to canoe for to travel a distance of 35 kilometers? So again, we're going to write down what we know. We know our speed, VAV, is 8.2 kilometers per hour. Okay? So I have to have my symbol, and I have to make sure I put my units in. We know that the distance traveled is 35 kilometers. Okay, so my D value is 35 kilometers. And it says, how long do they need to travel? So I am looking for time. Write down what I know and what I'm looking for. I write down the equation that I need. Now, you have the equations manipulated on your equation sheet. So you can just look it up. What is the equation for time? Okay. Distance over speed. Okay. Let's see. Distance, I know, is 35 kilometers. Speed is 8.2 kilometers per hour. Take 35, divide it by 8.2, and what do we get? 4.26. Does everyone agree? Okay. 4.1? 27? Okay, try it again. We need to have the consensus here. 4.27? Okay, 4.27 hours. Well, do I have the correct number of sig figs there? No, I can only have 2 sig figs. So my answer is going to be 4.3 hours. For some people, you will just have to trust me that hours is the unit that comes out. I'm going to show you once why that happens, and then we'll just assume that it's true, okay? So what happens here is I'm taking my kilometers and dividing it by kilometers per hour. We agree with that? When I divide by a fraction, what do I do? Multiply by the reciprocal. So this is the same as kilometers times hours over kilometers. Perfect. The kilometers cancel, and I'm left with the time unit. Okay, so that is what's happening there. Questions? Okay.
Is
Yeah, a little late, not enough room anyway. Okay, a pitcher pitches the ball at an average speed of 28 meters per second. So I know my V value is 28 meters per second. Or I could put VAV. Remember, we can use it either way for average. What is the average distance? So I'm looking for distance if the ball travels for 5 seconds. So I read the question, write down what I know, what I'm looking for, then find my equation. And again, it's on your equation sheet. So what is distance equal to? Yeah, distance is equal to speed times your time. Speed is 28 meters per second. Time is 0.5 seconds. And so now I have to find out my distance. So 28 times 0.5 is? 14. And my unit is meters. Why? Because my seconds cancel and I'm left with a meter unit. Now, that is it for now. We are going to now do our questions in your booklet. Turn that off.